Thank you, everyone, for joining us today from different parts of the world. My name is Abbas Jafar, and I'm the Communications Manager at the Institute for Global Health and Development at Aga Khan University. It is my pleasure to welcome you to the IGHD webinar on climate change and agricultural solutions impact on nutrition. Please note that this session is being recorded and will be available on our website within a week. The website address I will paste in the chat later on. Before we start, I would also like to request that attendees keep their microphones muted to avoid unforeseen disturbances during the presentation. To facilitate your engagement, we have enabled the chat functions for questions, comments, and networking. Feel free to introduce yourself with your name, organization, and location in the chat. We have also enabled the Q&A function for specific questions to be addressed during the discussion. All questions should be asked using the Q&A function. If any of your questions remain unanswered, I will forward them to the relevant panelists and share the responses via email. Also, for those who are interested in receiving a certificate of attendance, a link to the form will be provided in the chat near the end of the webinar, through which you can register for it. For the sake of time and for your reference, I will be sharing brief bios of our speakers in the chat as well. Now, let me introduce our esteemed host and moderator, Dr. Jay Das, Assistant Director of the Institute for Global Health and Development at Aga Khan University. Dr. Das, over to you to introduce our speakers and guide us through this session.
Thank you. Thank you, Abbas. And Assalamu alaikum. Good morning, evening, afternoon, wherever you are. So it's such a pleasure to see you all here and on such an important topic, especially considering the current context that we are going through, and especially how relevant is this topic for Pakistan. Because all of you know that climate change is a harsh reality, which is affecting each and every avenue of our lifestyle. And no one is spared. Everybody is getting impacted, and it's impacting their health, their lifestyle, their earnings. So a lot of impacts that this climate change is having on many people, and especially for the populations living in the developing world context. And unfortunately, Pakistan is one country which is facing a diverse array of climate change hazards. And one of the important sector is agriculture. So agriculture is the backbone of our country, whether it comes to revenue generation, whether it comes to employment opportunities. And unfortunately, this is the sector which has been affected the most. So today we are gathering here to discuss on this pressing global challenge and how it is intertwined with our food systems, communities, health, and nutrition. And as climate change continues to reshape the environment, it also poses significant risks to agriculture productivity and in turn our nutritional security. So the aim here is to foster a deep understanding of these issues, share innovation solutions, and inspire action that can lead to a more sustainable and resilient future. So we're very excited that we have been joined by an esteemed panel of experts who have done a tremendous amount of work in our context. And within this next 60 to 90 minutes, they are going to share the experience and tell us what could be done, especially in the context of Pakistan. So without further ado, I think we'll start. So our first speaker for today is Dr. Shaukat Ali. So Dr. Shaukat Ali is an associate professor at the University of Agriculture, Faisalabad. He specializes in agriculture extension, education, and rural development. He has led pioneering initiatives like the Cyber Extension Project and the University of Agriculture, Faisalabad FM radio for agriculture outreach. He has around 40 published research papers and 5 books to his credit, and he has helped shape agricultural practices in Pakistan. He also serves as the editor of Zarai Digest and holds various administrative positions at the University of Agriculture, Faisalabad, and also contributes to national and international agriculture policy and education. So Dr. Ali would be presenting on the topic titled Bridging Traditional Practices and Climate Adaptation for Better Nutrition. So over to you, Dr. Ali.
Thank you very much for your kind introduction, Dr. Jayabad. And
Dr. Lee, can you speak a little louder?
Dr. Ali, you're muted.
I'm just sharing this again.
Dr. Lee, we cannot hear you properly. Are you using a mic or a laptop?
Yeah. My screen is
He's muted.
sharing now.
Jay.
I'm audible now.
Yeah, better. But yeah, speak a little louder and closer to the mic. So thank you for that.
Okay. Okay. Thank you very much. Thank you very much.
And one more request.
Dr. Shaukat Ali,
can you make a presentation full screen in the presentation mode? Just at the bottom right.
Yeah. Thank you very much. So today I will talk about bridging traditional practices and climate adaptation for better nutrition. I'm Dr. Shaukat Ali. I'm working as associate professor in Institute of Agricultural Extension, Education and Rural Development in University of Islamabad. Pakistan is ranked among the top 10 most climate vulnerable countries in the world in the Global Climate Risk Index. And I think in the context of Pakistan, it's the common knowledge that we are at risk. Pakistan is at risk, is at threat according to the climate change scenario. So the main driver of climate change is the greenhouse effect. And major greenhouse gases are carbon dioxide, methane, nitrous oxide, and fluorinated gases. And we know that burning coal, oil, and gas produces carbon dioxide and nitrous oxide. Similarly, cutting trees, I think.
Dr. Lee, we cannot hear you again.
Yeah. And cutting down forest, such as deforestation, is also something disturbing. And cutting down forest, such as deforestation, is also a cause for rising emissions. Similarly, increasing livestock farming, in which cows and sheep produces large amount of methane. When they digest their food, they emit methane gas, and it contributes significantly toward greenhouse gas emissions. Similarly, when we talk about fertilizer, chemical fertilizer, inorganic fertilizer, fertilizer contain nitrogen, which produces nitrous oxide emissions in the atmosphere. Similarly, the fluorinated gases are emitted from equipment and products that use these gases. So these are the various sources which emit greenhouse gases in the atmosphere. So it creates greenhouse effect, and greenhouse effect basically create the challenge for climate change, and climate change is a threat to agriculture because due to climate change, what is happening? The temperature is increasing. In the past 30 years, the mean temperature across the country has increased by 0.5 degrees centigrade. Similarly, there are increased threats of drought and rainfall. On one side, we are facing drought, and on the other side, we are facing rainfall. I mean, extreme conditions we are facing in the era of the climate change. So this is the projection. And it's really very concerning that by 2050, the temperature in Pakistan will increase up to 2.8 degrees centigrade. And it is a significant increase in temperature. This temperature, about 3 degrees centigrade temperature, can alter the cropping pattern, and it can disturb the cropping pattern, the cropping sowing time, and cropping harvesting time. It can significantly decrease the yield as well. Similarly, on the right side of the slide, we can see that there would be changes in total precipitation. And we can see that on the right side of the Pakistan, on the northeast of Pakistan, there would be a 3% increase in the rainfall, while on the west side of Pakistan, there would be less rainfall. It means on one side there would be a flood, while on the other side there would be a drought. So both conditions, floods and droughts, are obviously posing challenges to our agriculture. So this slide reflects that how climate change would impact on yield, crop area, and livestock numbers in Pakistan. So we can see that here, the wheat crop, cotton crop, rice crop, and sugarcane crop. So these crops, the yield of these crops would be decreased up to 3%, up to 2030. So it means that up to 2030, the yield of these crops will be decreased up to 3%, while in 2050, the yield of these crops will be decreased up to 6%. And in the case of maize, the situation is more worse. In maize, the yield will be decreased up to 12%. And same is the case with the chickpea, tropical fruits, vegetable. So it means in the coming years, in the coming decades, the yield of agricultural crops would decrease. We are facing the climate change threat in spite of the fact that the share of Pakistan in global greenhouse gases emission is not much significant as compared to other countries. We can compare Pakistan with other 17 countries. For example, the China contribute 29%, United States contribute 11%, India 7%, Russia 4.8%, but Pakistan on the 17th number contribute only 1%. So Pakistan is not a big contributor to GHG gases, but even then we are facing the issue of the climate change. Within Pakistan, if we see that what sectors are contributing toward climate change, we can see that the top of the list is the energy sector. 44% greenhouse gases emissions come from energy sector, and agriculture is the second largest sector, which contribute 41% to greenhouse gases. Even if we see in the agriculture sector, we can see that 78% greenhouse gases comes from the livestock sector, while 22% gases come from the crop sector. In the crop sector, we can see that crop residues is also a source. Crop cultivation, synthetic fertilizer contribute 14%, manure contribute 3%, but the enteric fermentation contribute to 54%. So we will discuss the case in the next slides. So this was the background. So in these circumstances, when temperature is rising, more rains, more floods, food conditions, how we can adapt uh, with the climate change by using traditional practices. I am focusing on traditional practices because more than 80% farmers in Pakistan are small farmers. And at this point in time, it's really hard for the farmers to adopt the modern and costly agricultural production technologies. We can say that smart agriculture, climate smart agriculture practices may be difficult for the small farmers, for the resource poor farmers. So it is highly recommended that our farmer must adapt the climate change by using the traditional practices. So what farmers can do? Farmer can use heat resistant varieties. For example, if we talk about wheat, so there's a variety Lasani 2008, which is relatively heat resistant varieties. Basically, the wheat crop is really sensitive to heat during the month of February and March. So in these months, Lasani 2008 variety can tolerate heat, can resist heat. And the other factor is, and the other aspect is that our breeders should focus to develop on heat resistant varieties. And obviously, scientists are working on it. University of Agriculture, Faisalabad had imported the germplasm of heat resistant varieties from University of Washington State, and trials are on at the university campus, and the results are really encouraging. So we can expect that in the incoming few years, the heat resistant varieties maybe with the farmers, the field, and which may not affected by the climate change or by the heat wave during the month of February and March. So the other aspect is we should use local varieties, or we should focus more grow the local crops. For example, millet, for example, gram. These are the native, these are the indigenous crops. These are more resistant to heat. These are more resistant to drought. These are more resistant to frost. So this is one of the options that we can use local varieties, or in other words, we can use native varieties. The third one is the irrigation practices. So we can irrigate the crop to avoid crop from frost and heat. For example, farmer usually adopt this practice. Potato farmers adopt this practice. When there's frost, farmer irrigate the crop to avoid the frost. Irrigation during frost hours can minimize or mitigate the effect of the frost. And same is the case with the heat. For example, if there's a heat wave, irrigation is very important. If we irrigate the crop at proper time, at the time of heat wave, we can save our crop from the heat shocks. So irrigation practices can also mitigate the effect of the climate change, or we can say that it's also a adaptation practice according to the climate change. Organic matter is really important. Organic matter, if our soil has sufficient organic matter, for example, organic matter of more than 1%, more than 1.5%, if we have organic matter in the soil, such soil can tolerate heat as well as cold. So this is another practice which our farmers can adopt. Mulching is very important. Mulching mean to cover soil with the residues or with the cover crop. So mulching is very efficient tool to avoid heat and cold. Sowing time adjustment in current era of climate change is really important. For example, in the current crop, currently our farmers are facing it, that those farmers who cultivated, who have sown the ice crop, early crop, it resulted less grain formation. And there is a hue and cry in the field, in Punjab particularly. Those farmers who have cultivated their crops little later, they are on the safe side. But early sowing farmers are really in trouble because there is no grain formation in the rice crop. Similarly, late sowing of spring maize is really problematic for the farmers, because if farmer sow the crop in the month of February, so month of February, it would be a trouble for the farmers in the month of May and June, because it would be the pollination time, and heat wave will definitely affect the pollination of the crop, which will be resulting in the less yield. Another very important practice is the raised bed sowing. Raised bed sowing is really important. I can give example from the current season. For example, there is a really a devastating situation in the sesame crop in Punjab particularly. But those farmers saved their crops who have cultivated the sesame crop on the raised bed, because raised bed save your crop from excessive water. Excessive water is really damaging for sesame crop and cotton crop. Next is the application of micronutrients. Micronutrients is very effective adaptation strategy to avoid heat. There are micronutrients which we can apply to avoid heat, which we can apply to avoid cold. Potato farmers usually use this practice. During frost, they apply micronutrients to save their crops. Similarly, application of cold water is also a mitigation and adaptation strategy. Application of cold water means spraying the cold water in the heat. So this is an adaptation strategy to avoid heat. The other strategies we can use to mitigate the climate change, particularly to mitigate the greenhouse gas emissions, or to mitigate the greenhouse gases in the atmosphere. Tree plantation is really important. Obviously, tree consume carbon dioxide, and carbon in the atmosphere, trees are able to fix it. Similarly, fuel saving is important. Energy efficient machinery is really important. Minimum tillage is important. If we disturb our soil minimum, then there will be less emission of the greenhouse gases. Use of organic fertilizer is important factor. Land leveling and crop rotation. By using judicious, sensible crop rotation, particularly adding the leguminous crops, we can minimize the demand of the inorganic fertilizer. So these could be the mitigation and adaptation strategies, traditional strategies already in practice. If we use these practices sensibly, we can cope with the condition of the climate change to grow crops healthy and to increase the productivity of the farm. Thank you very much. I would like to have a question.
Thank you. Thank you, Dr. Ali, for this tremendous presentation telling us the mitigation strategies when it comes to using traditional practices in agriculture. So for the questions, what we'll do is we'll ask all the attendees to put their questions in the Q&A section. And after all the three speakers are done with their talks, then we are going to take the questions together. So please put your questions in the Q&A section, and then we'll take them at the end of this talks of the three speakers. So with this, I'm very happy to invite our next speaker, who is Dr. Misbah Nausheen. Dr. Misbah Nausheen is an academic and researcher with over 18 years of experience in economics. Currently, she is serving as an associate professor, and she is a chairperson of the Department of Economics at Aga Khan University, Mansehra. She holds a PhD in economics and has completed her postdoctoral research at the University of Nebraska, USA. Her areas of expertise include macroeconomics, development economics, climate change, and gender studies. Dr. Nausheen's research has been widely published in leading academic journals, and she is dedicated to addressing socioeconomic challenges and promoting sustainable development in her work. So with this, I'd like to welcome Dr. Nausheen, and the topic that she'll be presenting on is gender, agriculture, and climate resilience, strategies for closing the nutrition gap in rural communities. Over to you, Dr. Nausheen. Dr. Nausheen, can you unmute yourself? Dr. Nausheen, you're muted. Yeah. Okay.
Thank you so much. The title of my speech is Gender, Agriculture, and Climate Resilience, Strategies for Closing the Nutrition Gap in Rural Community. This speech is based on a qualitative research, and it is grounded in document analysis and expert views analysis. It emphasizes its significance within the study. Previously, I have conducted research focusing on the prospects of women in rural communities, which is published in an international reputable journal. So I would like to introduce the topic. So, achieving effective gender mainstreaming in the design, implementation, monitoring, and evaluating of policies is considered critical by academics and international organizations for meeting national development goals. The intersection of gender, agriculture, food security, and nutrition, and climate change has been extensively studied, highlighting its significance not only for addressing gender inequalities, but also for tackling climate change and food security nutrition challenges. However, research addressing the integration of gender in the policy cycle, particularly concerning the nexus of gender, agriculture, food security, nutrition, and climate change remains scarce. In the agriculture sector, which serves as a primary source of employment for women in rural areas of developing countries like Pakistan, gender consideration are especially important. Despite their vital contribution, women often have less access to essential resources such as land, inputs, education, financial resources, and technology. So this inequality not only affects agricultural productivity, where the gender productive gap can range from 4% to 25% depending on the country and crop, but also result in female headed household facing higher vulnerabilities to become shocks and poverty. Gender impact of climate change. Women face significant challenges from climate events like drought, floods. Existing inequalities are exacerbated by climate change. So there are different opportunities for gender sensitive interventions. Climate adaptation strategy need to address women vulnerabilities and strengths. Gender sensitive policies can enhance resilience and agricultural practices. So limited qualitative research on women experiences in climate resilience and their nutritional impact, along with insufficient understanding of the cultural and social barriers hindering their participation in climate change strategy. Additionally, the importance of document analysis and expert interviews in assessing these dynamics is under research. So this study is based on the theoretical framework. So this theoretical framework has 3 dimensions, and it is a gender, climate change, and nutrition integration framework. It emphasizes connection between gender inequalities, climate change, and nutrition. It shows that women vulnerabilities stem from limited access to resources, decision-making power, and their role in food production and caregiving. So key sources integrated resilience framework. So it is based on, basically it is given by Brian 2014, but it is based on different frameworks like resilience framework given by Frank Berger et al. 2014, IFPRI's Gender and Climate Change Framework, Berman, Bryan, and Go 2014, and Global Nutrition Report 2015, Spring Agriculture for Nutrition Framework, had Forth and Harris 2014. So this theoretical framework, I earlier said this has 3 dimensions. So this integrated framework for gender, climate change, and nutrition has, on this slide, it has this generic version. So it shows a general framework linking gender, climate change, and nutrition. It highlights how these 3 domains are interconnected and how they interact to influence resilience at different scales. For example, individuals, households, communities, and nations. The framework does not list all the factors influencing resilience, but it gives a broad overview. The climate science, for example, shocks and long-term changes, interacts with the enabling environment, policies, institutions, and international factors to shape absorptive and adaptive capacities, influencing how different actors respond to climate challenges. The framework also outlines pathways through which these responses impact well-being outcomes, including food security, environmental sustainability, gender equality, and health. This is this is the second version of this framework, household level insights. This adapts the general framework to illustrate the factors at play at the household level. It emphasizes how climate shock and stressor influence household absorptive and adaptive capacities. At this level, key factors include The livelihood diversification, health status, financial assets, and social safety nets of individuals and households. Moreover, this illustrates how households with higher absorptive capacities, such as those with diversified income sources or better health, are better able to cope with shocks. Moreover, factors like access to information, gender role, and time constraints shape the adaptive capacity of households. Gender disparities are particularly significant at this level, as women often face barriers to accessing information, resources, and decision-making power, limiting their ability to contribute to household resilience. The third version of this theoretical framework is policy considerations. This adopts the general framework to focus on policy level sectors. It highlights how national and international policies, institutions, and commitments influence the absorptive and adaptive capacities of countries and regions. For example, international aid flows, political stability, and investment in science and technology play key roles in shaping how nations respond to climate shocks. At the policy level, factors like GDP, health system, and market access also determine adaptive capacity. This shows that decision making at this level is influenced by complex negotiation among actors with varying level of power, resources, and interest, which can result in unequal outcome that might not address the needs and priorities of marginalized group, especially women. Research design and methodology. The aim of this research is to explore intersection of gender, climate change, and nutrition in Pakistan, focusing on women in agriculture and food security. We have used the method document analysis, review key policies, NCCP, CCGAP documents, gender vulnerabilities and gap. And this study is also based on expert interviews. These interviews are semi-structured interviews with to gather qualitative insight. So on this slide, we have used 12 policy documents related to food security, nutrition, gender, climate change, risk management, and environment. And the law policy documents, program documents, and national action programs, a national action plan, or the document type. And this study is based on 10 interviews. And date of interview, September 2023 to October 8, 2024. If I already mentioned that, although I have not included the interviews, the perceptions of women, I have also, I just included the document analysis and expert views. And the perceptions based on the study based on the perception of women has been published in 2023. Participating organization, the Ministry of Climate Change, IUCN, Green Climate Fund, Agriculture, Food and Livestock, UNDP, UN Women, and UNFPA. Key findings from document analysis. The theme is the first theme is gendered vulnerability to climate change. It has key insight. Women in rural areas are disproportionately affected due to their reliance on natural resources. Gender disparities exacerbate their vulnerability. So, key figures and facts are Pakistan ranked 153rd out of 156 countries in the Global Gender Gap Report 2021, illustrating deep gender disparities. The second theme is women role in climate resilience. So key insights from this theme, women play a critical role in natural resources management and resilience, building effort in multiple sectors. So facts and figures, women leadership is highlighted in the priority sectors like disaster risk reduction, agriculture, and biodiversity, etc. The third theme is inclusion of women in climate policy and decision making. So a key insight is women inclusion at all level of climate policy making is essential for responsive, effective adaptation initiatives. Facts and figures, less than 10% of women are involved in policy making or governance roles at the provincial or national levels in Pakistan. Number fourth theme is gender sensitive adaptation measures. So key insight, adaptation strategies need to consider the different ways men and women experience climate impact with measures that prioritize women's needs. Women contribute 60 to 80% of labor in the agriculture sector, yet are often excluded from formal climate resilience efforts. Fifth theme is building knowledge and capacity on gender and climate change. Key insight, increased understanding of gender role is required in project planning alongside capacity building efforts. So facts and figures are women's participation in climate action remains low, with only 15% of women involved in local level capacity building program. And number 6 is gender responsive budget and resource allocation. Resources should be allocated equitably, ensuring gender responsive budget that address women needs in climate adaptation efforts. Less than 5% of climate related projects in Pakistan include gender responsive budgeting. Number 7, legislative and policy framework for gender equality. Significant gaps exist in implementing policies that promote gender equality in climate action. So facts and figure, only 18% of national policies addresses the need of women in climate adaptation and resilience building efforts. Here we have key findings from expert analysis. It has key themes, then description and quotes. The first theme is impact of climate change on women in agriculture. Description, women in rural areas are disproportionately affected by climate change, facing significant risks to their livelihood. Quote, extreme weather events are reducing crop yield, increasing food insecurity.
Right. So thank you, Dr. Machine, for taking us through your topic, and it was great presentation that you talked about the gender gaps even in agriculture policy and implementation. So I would again request all the participants to keep posting the questions in the Q&A sections, and we'll come back to responding these queries after this final talk. So I'm very pleased to invite Dr. Huma Salim for our final talk of this webinar. So Dr. Huma Salim is an assistant professor at the Department of Plant Breeding and Genetics based at the University of Agriculture, Faisalabad. She has extensive experience in plant disease resistance breeding. Her expertise encompasses molecular biology, virology, bioinformatics, and with a focus of enhancing field crops resilience to biotic and abiotic stresses. Dr. Salim has published extensively in peer-reviewed journals and is committed to promoting sustainability through initiatives such as the Plantation Drive and the Zero Plastic Offices. So with this, I'd like to invite Dr. Salim to talk about the topic of her presentation is breeding climate resilient crops, a key to ensuring food security and advancing crop nutrition. So over to you, Dr. Salim. Dr. Salim, can you hear us? Okay, right.
Yes.
All right, so please share your screen and thank you.
Can you see it?
Yes, please proceed.
Thank you so much, Dr. Chedas, for a brief and comprehensive introduction. And thank you for the organizers of Aga Khan University for providing me the opportunity to speak on this an important event, important issue. And I'm going to speak on the breeding climate resilient crops, a key to ensuring food security and advancing crop nutrition. First of all, I just want to discuss a little about what is global climate change and how it is impacting us. With the increase in mean temperature worldwide, we are facing more frequent, longer, and more intense extreme weather phenomena such as droughts, heat waves, and floods, which we are experiencing every day. And these could be devastating for a crop if it is happening at the time of pollination, which ultimately affect the fruit production and the yield of the crop. We are facing several other things, which are the losing biodiversity, yield reduction, loss of wild species, and lower precipitations at the time when we need it actually. Limited availability of water for irrigation, because sometimes when we need water, that water is not available. And sometimes when we don't need water, it is abundantly available. And which is, in both cases, it is harmful for the plants. These all are some points which are ultimately affecting the crops and ultimately the human population. What is actually the global trend is going on? As in this picture, the 1/3 of the emissions, the global emissions, which result in the global warming, it is through the agriculture. So to control these emissions is the first place to check out these events. Global warming, it ultimately leads to more heat and drought events, which leads to more demands of the irrigation. And when we use irrigation, then it increases the salt in the soil. So many people think that the climate change, it means only the warmer temperature, or it's the higher temperature, or the global warming. It's called the climate change. But temperature rise is only the beginning of the story, because the earth is a system. It's a whole system where everything is connected. Changes in one area that can influence a change in all other areas. So what we actually need as an agriculturist, as a researcher, we need climate smart agriculture. So what is climate smart agriculture? It is an approach which to develop the technical, policy and investment conditions to achieve sustainable agriculture development for food security under climate change scenario. It has three major objectives. Number one, sustainably increase agricultural productivity and incomes. Number two, adapt and build resilience to climate change. And number three, reduce and or remove greenhouse gas emissions where possible. But we will target the first two objectives according to FAO. According to climate smart agriculture, the FAO strategic framework 2022 to 2031, it based on the four betters. These four betters include better production, better nutrition, better environment, and better life. So better production and better nutrition, that is in the hand of a plant breeder and farmer. And for providing the right platform, the right technology, and right research is our goal. So the first is breeding climate resilient crops. Plant breeding has always been an important in human history, and it always revolutionized the agriculture, and it feeds the world continuously, the increasing population. So according to United Nations Sustainable Development Goals, which we call the SDGs, it has more focus on the global food demands, which is predicted to be increased by 70 to 85% as the population will increase by over 9 billion by 2050. And what actually we are facing due to these climate change events, we have reasonable varieties, but at the time of giving fruits and at the time of harvesting or the critical stages, these varieties, they get collapsed. So we need the climate resilience in our existing varieties. So why breeding matters at that point? Because we continue to grow enough food despite these environmental challenges, because environment will remain the same, rather it will get worse with the passage of time, with the increasing population and with the human activities. What are the key traits which we required are the drought tolerance, pest resistance, nutrient use efficiency, soil tolerance, and the ability to grow in integrated soils. Objective 1 and 2, as I have already mentioned, it is the increased productivity and yield, and number 2, enhance resilience to environmental challenges. The normal crops, as in figure which is on the top, we have the water, sunlight, and nutrients, and our defense reaction. Plant is giving the normal growth, biomass, and yield. But what actually we need in the climate smart crops, we need more defense reaction for biotic and abiotic stresses. What were the past efforts actually, and what we have achieved? Climate change impact yield and productivity, and scientists, they keep on doing their efforts, and the green revolution is the main example. But what is the result of that green revolution is the loss of genetic diversity. Then another era where there is the massive use of synthetics such as fertilizers and pesticides and herbicides, which is not a sustainable use or sustainable or a wise approach. The other one is the intensive mechanization. Due to intensive mechanization, it increases the emissions, which result in the global warming. And increase in the agricultural land. By increasing the agricultural land, ultimately we are cutting the forest. So these are the 4 points which actually in the previous 70, 80 years, the continuous research, but we are gaining something, but meanwhile we are losing something. Now we move to the other era which we call the era of biotechnology. In the first generation, we received the varieties which are herbicide resistant and insect tolerant. And in second generation, now we are focusing on the nutritional value of crops. But besides all this, there is no effort which is to introduce to complex polygenic traits to mitigate the climate challenges. How to overcome all these and how to handle several things side by side, we need to use the advances in breeding for climate smart agriculture. The post-genomic era has introduced some powerful tools such as next generation sequencing, in which we have CRISPR-Cas techniques and high throughput phenotyping. And these technologies these enable the faster identification of traits which are related to stress tolerance and nutrition improvement. This is a complete outline how the plant responses when there is elevated carbon dioxide in the environment, high temperature. So what are the overall biochemical, physiological, and structural changes happen in the plant? But these are 4 major techniques in the genomic era or in the molecular era, which are going on, through which we can develop several climate resilient crops. And we have several success stories, which I'm going to tell you later on. Actually, plant breeding is not a solo science. We need several integrated approaches where we pick the germ plasm, we need precision agriculture, we need trait discovery, we just play with the genes, and then biotic and abiotic resistance can be achieved. Here, there are different physiological, morphological, metabolic, and reproductive alterations, which we can make in the plant by using all these phenomics, genomics, transcriptomics, proteomics, and metabolomics techniques. These are all advanced breeding tools which are currently being incorporated in the labs. So till my previous slides, what I actually want to communicate that what we need is a next generation green revolution. And what we will achieve, and what after that we will achieve food security. And we need a comprehensive and more sustainable development agriculture in that way. So from this slide, we are focusing on the UN second SDG to eradicate the extreme hunger and malnutrition while promoting the food security. Actually, there are 4 interventions which comes under the food security: food diversification, food fortification, food supplementation, and biofortification. These 3, which I have 1, 2, and 3, which I have mentioned in earlier, these are actually just to manipulate the food by adding or mixing or taking food in different ways. But biofortification is actually in the hand of plant breeders. It is the process of increasing the micronutrient content of a food crop through selective breeding and genetic modification, or the use of enriched fertilizer, which we call this agronomic biofortification. So here you can see in the picture just one small biofortified orange-fleshed sweet potato. It can provide one child's daily vitamin A needs. The golden rice, the famous golden rice, which continuously the the rich countries, they are supplying to the Africa or the poorer countries, they are continuously supplying the vitamin A requirements of the African people. So these orange-fleshed varieties, they are rich in beta carotene, and they provide the good energy source and vitamin B, C, and K. Another way to improve the resilience and nutrition is the pangenomics. Plant breeding programs, they can deliver improved crop varieties and minimize the risk, which is actually posed by these unpredictable extreme weather events. The integration of genomics and phenomics, they combined with efficient database management and modeling, they can be used to unlock the genetic potential of gene bank or germplasm. Basically, it involves the analyzing the entire gene pool of a species where there are some genes which are already missing from a reference genome. So by using these pangenomics, we can identify those missing genes and then incorporate those genes in the cultivated varieties to improve resilience and nutrition and yield. Another way to improve the resilience is the harnessing crop wild relatives for genetic diversity. Crop wild relatives have abundantly favorable genes, or we can say they have the rich treasure of abiotic and biotic tolerance resistance genes. And several breeding programs worldwide are going on where scientists have successfully integrated different traits from wild species into cultivated crops in wheat, tomato, alfalfa, chickpea, potato to improve their resilience and nutrition. CRISPR and genome editing is the famous tool of biotechnology, and the scientist, Ms. Jennifer Doudna, the famous Nobel Prize holder, she has changed the total molecular era by the discovery of this genome editing techniques. Several resistant genotypes were introduced in corn, potatoes, tomatoes, rice, wheat, and there are several going on in different labs in Pakistan as well as in world countries. Seed breeding for rapid crop development is an advanced technique abundantly using in various labs in Faisalabad Agriculture University and as well as in Islamabad, where controlled environment has been used to accelerate crop growth cycle, where we can use 4 to 6 crops can be achieved in 1 year. Here we can develop one variety which we by breeding efforts, which actually we achieved after 8 to 10 years. By using speed breeding, we can get a variety in 4 to 5 years. So machine learning and artificial intelligence, these actually make the life easy for several scientists. So several machine learning algorithms, they can predict the stress responses by identifying valuable genetic traits from large data sets. Their predicted models, they introduce different chips to by using different climatic modules and by using different AI tools for the crop phenotyping and genotypic selection for enhancing the breeding efficiency. Genomic assisted breeding is also using, is extensively using nowadays, and rather it has been using since 20 years, but with more advanced in ways, now we are using it by marker assisted selection and QTLs. We are incorporating actually the AI tools and machine learning with this genomic assisted breeding. Here this is the complete outline of, I can see that I have time. So these are the complete outline for genomic assisted breeding for climate smart agriculture. So these are the crops which have been developed after the genomic assisted breeding. So climate smart agriculture and sustainable practices, they also been using where we integration of trees with crops and livestock. Trees can act as windbreaks and they reduce erosions and provide shades and helping crops to withstand heat and drought. Now I will mention 3 new crops which I have the success story which we are using and several scientists are using. The new crops have been incorporated in our agriculture where to use as a dietary diversification, the quinoa, which we use in the multigrain flour, and it can increase the diet, it can enhance the dietary requirement, it can fulfill the dietary requirement, and it can reduce the malnutrition. There is another crop which is introduced, it has been introduced in previous years. It is a tritodium. It is a hybrid between durum wheat and barley wild relative. As I have mentioned that the wild relatives have been incorporated in the breeding programs. And the teff, it is basically the Ethiopian origin crop, but now it is extensively being used in or mixed with the normal flour to enhance its protein and starch content. There are some other innovative climate smart breeding through cross-species integration. And here are 2 projects which are very important to mention here. One is project Darwin 21, which is established in King Abdullah University of Science and Technology, where they are actually identifying how the rhizospheric microbes in the desert area, how they are actually performing well while there is less water. So they are taking the genes from those plants and their rhizospheric microbes and then incorporating into the commercial varieties. And the other one is the microbial endophytes of halophytes. It's the project of University of Valencia, where they are incorporating the microbial endophyte. They actually characterizing the microbial endophyte population, which is actually associated with those halophytic plants which are successfully growing in the salt habitats. In this way, they can evaluate the possible applications of the endophyte as a crop biostimulants. So these are actually the latest and innovative plant breeding approaches for improving the resilience in the crops. Thank you for your attention. And one last thing, which is very important to understand, we are the first generation to feel the impact of climate change and the last generation that can do something about it. Thank you very much.
Thank you. Thank you, Dr. Salim, and such a great talk and a very pertinent quote at the end that this is the time to take action. So with this, I'm very pleased that we had a very enlightened session and had a great talk from all the 3 speakers. So I'll be moderating a session. So we have a few questions and answers, but before going to those questions, I just take the liberty of being a moderator and I ask a couple of questions to the speakers before we move to the Q&A. So first to Dr. Ali. So Dr. Ali, you talked about the traditional practices and what climate adaptation measures are being incorporated into agriculture. So I have some very limited experience in agriculture. So I'm a very novice in this area. But as we all know that the focus of the farmers is always on the yield. So what do you think that how has been the uptake locally in Pakistan when it comes to traditional practices or these newer seeds varieties? And what do you think could be done to improve the uptake of these varieties within the agriculture sector of Pakistan?
Yeah, thank you very much. Basically, first important thing is.
Dr. Ali, can you please bring the mic closer? Yeah.
Yeah, thank you very much.
Yeah.
Yeah, thank you. First of all, it's really important that we must have varieties which are climate resistant, which are resistant to heat, which are resistant to frost. And I think we are in the process of developing heat resistant varieties and frost resistant varieties. Once we have our varieties, then the only strategy is to disseminate information about that particular varieties among farming community, technology transfer techniques. That the setup is already existing in all 4 provinces in the name of Agricultural Extension Department. So Agricultural Extension Department can educate farmers about the latest varieties, about the newly developed varieties to adopt. I think it's the only strategy that we can convince farmer to adopt those particular varieties.
Thank you, Dr. Ali. So my next question is for Dr. Nausheen. You talked about this gender parity and its impacts in agriculture. So what do you think could be the top measure which could be taken, which could have some immediate or short-term results, which could, in terms of increasing the voice of women when it comes to policy for agriculture, and also the ultimate impact on women in terms of working in the agriculture fields, in terms of their health and nutrition. So what do you think could be the one step which could be taken in Pakistan, which can have some immediate or short to medium term impact? Dr. Nausheen, you are muted.
Thank you so much. We have talked about National Climate Change Policy and Climate Change Gender Action Plan. So, policy implications based on my document analysis, and I have skipped that during my presentation. So, the first measure is strengthening gender responsive climate policies. So, first of all, it needs to revise the include clear, actionable, gender-sensitive strategies that address the specific vulnerabilities and contributions of women in rural and agricultural settings. Second is enhance women participation in decision-making. Structural barriers that limits women involvement in climate adaptation and policy development must be addressed. And the third one is expand gender-sensitive agricultural programs. Encourage and support women-led climate-smart agricultural practices such as tunnel farming that contribute to both food security and economic empowerment. And address the intersection of climate change and nutrition in the policies. So expand nutrition program like the SIN nutrition program, incorporating them into broader climate adaptation strategies that prioritize the need of women and children. And then data collection can be improved and research on gender and climate. So a systematic data collection on women's roles, contribution and vulnerabilities in the context of climate change is essential for informed policy making. This will help tailored intervention that are responsive to the specific needs of women across various regions. Thank you.
Thank you. And so my next question for Dr. Salim, you talked about breeding climate resilient crops. So first of all, what do you think is the most pertinent local success story that we can highlight in this area in terms of its uptake? And secondly, again, in a question from a non-expert, is there a difference in breeding non-climate resilient crops when it comes to cash crops versus food crops?
Actually, we have a lot of examples regarding climate resilience. We have several GMOs, especially in the previous 20 years. We have BT cotton, where we introduce a bacterium genes in cotton plant, and it can produce insecticide by itself. So now in cotton, there are the less number of insecticide or pesticides we are going to spray, and it can ultimately less harmful for the environment. And can you repeat your second question?
So yeah, my second question was, does this breeding climate resilient crops, does it vary between crops which are cash crops or food crops, or is the technique and technology at the same par?
Yeah, actually, when we say the crops, we can it includes everything. It includes fruit trees, or it's the shady trees, it's the crops, it's the vegetables, vines, everything.
Okay, all right. Thank you. So now coming to the questions that we have in the Q&A section. So Dr. Ali, there are quite a few sections on quite a few questions on GMO. People have been asking, like, are GMO seeds more weather resistance, and are they reproducible? Whether they are more productive when compared to the traditional varieties? Are they dangerous for human health? Do they give rise to cancers or impact women hormonal cycles? You're muted, Dr. Ali.
Yeah, thank you very much. The first question is that whether the GMOs are producible or not. So, of course, just like traditional varieties, the GMOs are not producible, and farmers have to buy the new seed in each season from the source, or particularly from the multinational companies. The next question is that whether the GMOs are dangerous or not. I think there is a debate, and the debate is continue, particularly if we talk about Europe. So Europe, basically, European Union discouraging the GMOs, and they claim that that GMOs are not health friendly. But if we talk about USA, the major organizations of United States of America dealing with the safety of the seeds, safety of the crops, they permit the GMO, and they claim that GMO is a safe. So there is obviously a debate, and the debate is still continue, and let's see that how it ends up. The next question is, what is the next question?
Question was related to this impact on women hormones and cancer. So health consequences of GMOs.
Yeah, I have talked about that as we, if we consider the opinion of European Union, then yes, it's not safe for health. But if we consider the opinion of USA, USA consider it safe. That's why I'm talking about that it's a continuous debate. In Pakistan, we are generally now allowing the GMOs because our major concern is yield. Obviously, the yield of the GMOs is definitely more as compared to the traditional varieties.
Right.
And I think the next question was that whether they are more resistant or not. So it depends. It depends from case to case. But if we talk about maize crop, then our local varieties are obviously more resistant to heat than the GMOs, and it has been happened around 2 years ago that the maize crop, particularly GMO based maize crop, you can see there was a crop failure due to heat. So I can safely state that in current circumstances, the GMOs are less resistant as compared to traditional varieties.
Right. And one more question for you. You mentioned the use of micronutrients in improving heat resilience. So there's a question, which micronutrients and for which crops? Is there an evidence that it leads to improved resilience to heat?
Yeah, obviously. Basically, the role of micronutrients is to increase the immunity of the crop. So if we increase the immunity of the crop, there are more chances that crop will face any shock. That shock may be in the form of heat, in the form of frost. So the micronutrients which are commonly used are there is zinc, there is boron, there is cadmium, magnesium, calcium, sulfur, similarly various protein even. And so these are the common, I can say, micronutrients which are being applied by the farmers, and it's a very common practice, and these micronutrients are available in the market.
Thank you. Thank you. So next question for Dr. Nausheen. There's a question that in your presentation, you talked about various policy documents that were evaluated for this study. So the question is, what was the approach that you took to get access or to search the policy documents? Dr. Nausheen, you are muted. Yeah, please go ahead.
I have consulted different policy documents. The main national climate change policy and the main documents for the climate change gender action plan, which is it is given by Ministry of Climate Change, IUCN, and two other different organizations. So it solely discussed the climate change gender action, solely discussed the gender part of the climate related to climate change and agriculture. So besides this is the main, these two are the main documents, and I have consulted other documents which are published by different organizations, international organization, for example, World Bank. So I have drawn different themes based on these documents, which are which includes gender vulnerability in climate change, women's role in climate resilience, and inclusion of women in climate policy and decision making, and gender sensitive adaptation measures, building knowledge and capacity on gender and climate change. And it is also based on gender responsive budget and resource allocation, and implementation and enforcement of and policy framework for gender equality. As reflected in the fact that.
Right. Thank you. Thank you for highlighting all of these documents. So next question for Dr. Humma Salim. So the question is that the use of technology is promising in ensuring food security. But how do these breeded plants are resilient to pests? Because as we know, the fertilizer and pesticides are the key products threatening climate change.
Yeah, so your question is to how these climate resilience, they can cope up the issues of the insecticide or
yes.
Actually, the climate resilience, it covers the biotic and abiotic both factors. So we have to target these two issues simultaneously without compromising the yield and quality of the plant, the nutritional value of the plant. And like if the plant is climate resilient and ultimately its yield is we are compromising on its yield and productivity, then it means our efforts are totally useless. So sometimes we change the area of the of that crop. We use some new areas, especially in the last 2-3 years. We have shifted cotton from Punjab to Balochistan because there was a lot of insect threshold in the Punjab area, and Balochistan is considered as the insect-free area so far. So, and now we are getting some good news from the Balochistan. So we are using multiple strategies to overcome the issues and achieving our target of climate resilience.
Thank you. Thank you. So we have a lot of other questions, but unfortunately, we are getting close to the time that we want to finish this webinar. So what we'll do is we'll circulate these questions. Abbas will circulate these questions to all the speakers and get responses which would be circulated to all the participants. So with this, I'd like to come to the end of this webinar, and I'd like to invite Professor Zulfikar Bhutta, who is a founding director at the Institute for Global Health and Development and a distinguished university professor at Aga Khan University, and also heads the Center for Global Child Health at Sick Kids, Canada. So over to you, Dr. Bhutta, for your closing remarks.
Well, thank you very much for this very interesting session. I must inform the audience that we deliberately tried in this particular webinar to have national experts speaking about agriculture, nutrition, gender issues, and I don't think you would have been disappointed. A lot of original data, a lot of insights from local policy relevance, assessment, as well as some of the emerging issues around opportunities using both the benefits of technology. Also, importantly, the issues of social drivers and determinants of health, which include pre-existing social conditions that can make some of the impact of climate and environment much worse. If there are gender inequities persistent or present in any environment, in any society, then you can impact consequences of environment and climate much worse in that particular subsection of the population because they don't have that level of resilience. They don't have those protective factors that are very important in taking things forward. So I know we are at time, and this has been a very fruitful, rich period of exchange. As Dr. Das said, we will put some questions out to our speakers so that they can answer them directly to people concerned. And I want to thank the organizers of this webinar, Abbas, as well as Dr. Das, for doing this for us. And we look forward to seeing you in a future webinar on similar series. Thank you very much, and Khuda Hafiz.
Thank you, all the panelists and Dr. Das and Dr. Bhutta for joining us today for this webinar. As mentioned before, I'm sharing the link as well for the certificate of attendance. It is now available on the, sorry, am I muted? Yes. No. So it's available in the chat, and please use that to register for the certificate of attendance. I will do my best to have all of these out to the emails that you've registered on within the coming week, 2 weeks. I will request your patience. There are a lot of people who've attended the webinar today, and it might take us a bit time to get through everything. A lot of you also asked about the video recording for the webinar. The recording will be available during the coming week. We will put it up on our website. The website address is being typed into the chat right now. As I've also mentioned, the remaining questions, I know a lot of people had a lot of questions, and thank you so much for being so interactive in the webinar. The remaining questions will be shared with our panelists, and as soon as any responses are shared with me, I will forward them accordingly to the registered email addresses. Once again, thank you all for joining. I will leave the window open for a while with the link for the website and the certificate of attendance. Please use that to register. If you face any problems, I will share the IGHD official email address as well in the chat so you can reach out. Once again, thank you very much.